So 5 minutes. Hopefully you have finished 7A. A couple of the questions so far from people have been with 12A. We sort of covered that in class a little bit last time, but if you weren't here or forgot, that's fine. You weren't up to it. Tan squared x. My suggestion for that one is work right-hand side to left-hand side, which goes against the grain. And once you've done that, you could probably then realize, oh yeah, if push came to shove, I could have gone left-hand side to right-hand side, because it's all about that replacing sine squared with, what's the connection between sine squared and cosine squared? Sine squared plus cos squared equals 1. So even if I've said this to a few people, can we just pay attention and then I will give it, so 5 minutes. Part B, the tip there, make sure, try and use your quotient rule and it should work out. If it doesn't, I'll come around and assist. With question 13, can you please just check when you are using your ln for your integral? As Hayden was saying, yeah, we just did that in methods. Absolutely. Okay, make sure you've got your modulus for when you've got your negative values. And remind yourself of your simplification rule. So at this point, I would have been happy if you had left it as ln of 1/3, obviously going from here to here, you've used your ln A minus ln B. Some of you are going, oh, that looks like pain for you, Mac. What's up? Forgot to. Okay, so ln A take ln B simplifies, but then you would also cancel that down. Now, you could leave it like this. Some questions will say, put it in the form A ln B, where A and B are integers. And again, we won't be saying A and B are integers. We'll just say A and B in Z. So that means integers. And so then you can say, well, this is 3 to the minus 1, and then it's minus ln a third. So just remind yourself, all of those rules that you used in methods, they're up for grabs here. All good? Okay. Now you're moving on to B, and I hate to tell you, I'll stick with it. I was going to say today we will do ln B, and tomorrow we'll do ln C, the substitution, but Ethan's already on to 7C, so see how we go. If we can move it along swiftly, that would be good, but some of these might get you stumped. So 7C1, we're basically looking at 3 new rules, and I don't think I have, I don't think I have to go through them individually with you. Sorry for the scrolling. I scrolled ahead because I was looking at something else. But we've got 1, 2, 3, 4, 5, 6 new rules. They are on your bookmark. It is fooling around with the inverse functions here. And remember, we have to make sure that we know the difference between, where'd it go? Right. So we've got x to the minus 1 is 1 on x, but when we have sine to the minus 1 of x, that does not equal 1 over sine. Okay? This is equaling arc sine. What is 1 over sine x? Cosec x, right? So we need to make sure that we know the difference. So there's no mix-up. We're now going to be saying arc sine. So that's what some of these rules are. If you look now at your formula sheet that I've given you, you're just applying. So you look at the rules on the left and you go, oh, what has a 1 take x squared with a root on it? Oh, arc sine. So we pull the 4 out and away we go. We do the same for B, right? I'll be honest with you, my first instinct is to pull out minus 5. But if you look at your rules, there is in fact a rule that is minus 1 over. So have a look at your book. Who hasn't got their little bookmark there with them? So I've used the rule and I get 5 arc cos x. If I had pulled out the minus 5, I get this and I've got 5 arc sine x. If you have a look at question 6, it's actually asking you this, exactly that thing. So somebody, what's the name they used? Question 6, let's have a look. Question 6. I want to say Andrea. Is it Andrea? Jill! God, I was nowhere near. Close. So Jill is doing the exact same thing, and you'll see which answer. Oh, Tegan. I was close. Andrea, Tegan. So we've got Tegan and Jill, and you'll see that they're the same. Okay? So you're just working through, as I said, some of them you have to fiddle with them a little bit to make them fit the rule. So pulling out common factors, sometimes timesing something by a value. So if you times the inside by 4, then you have to pull out a quarter out the front. Yep? So you're really just going through and we're playing around with the new rules, but same bizzo. So that's what we want to try and work through today. We've now got 50 minutes. Go your hardest and I'll answer any questions that you might have. Those playing at home, carry on. Those playing at home, can you feel free, email me with any questions that you have. Okay, so sorry for playing at home. We're just looking at exercise 7B and we asked the crowd what would be some of the ones you might want to ask if you were at home and you were stuck, and they came up with question 5A. So, hello, people, even if you're not up to it, looking this way. So we're at the point now where we know the rules and we should be able to do any. Just because you haven't got up to question 5 yet, we should still be able to use the rules and apply. So what are we thinking? Talk me through it. They're all silent. So I see the square root. So I'm looking at possibly here. Oh, that one's sort of looking, would you agree? That's looking the nicest, the closest. So we're popping that, trying to pop it in, and we go, okay, we've got the 1, that's nice. But what's my A? Yep, so we're happy that that's 1 squared minus, x squared. That's not actually going to fit that, is it? So that doesn't fit because I would have 2x squared, but that's not just a plain old x. So that's actually not going to fit that. What do we have to do? We actually have to pull out this factor of 4. So if I pull out a factor of 4, we've got the whole square root thing there. We'll ignore the fraction for the moment. If I pull out 4, what goes in my bracket? Aha, a quarter minus x squared. And now this will actually be able to fit the pattern because I can go, I can separate. Oops, jumping ahead of myself a little bit there. I can separate, pull out that square root of 4 out the front, right? And so now I've got, look at that, my 1 is back. I've got 1 quarter minus x squared. Oops, I should have put a square root there. Looking a little bit better, would you agree? And so this is now 1 over 2 square root 1 quarter take x squared. Can I just go willy-nilly straight into that? Yeah, it has to be a squared. So what is being squared? 1/2. Right, so I'm going to say I'm integrating now. The 1 over 2 can go right out the front of I like to just keep it out of my integral. Some people put it on the inside. I don't really care. But again, you're just using a little bit of algebra here to fiddle, to make it fit the rule. Does that make sense? So if you get stuck, call me over, but we'll keep on trucking. And while I have your attention, I'll leave it on, I'll pop this on, what's it called? The OneNote. But can you also all look at question 8 while I have you? Unless you don't want me to ruin the surprise for you. Do you want me to give you a few more minutes? Can I give you one hint? So they were talking you through and they're doing all of these sorts of things with 7 and they're saying show that equals, but then they get to question 8. Now I know some of you are thinking, because we did it last lesson, thinking polynomial division, but try not to. You possibly can do it a little bit quicker. My hint to you for this one is going to be, if I had 5 over 7, do you agree this is the same as 3 plus 2? And then why did I do that? Because I can then separate. So that's your hint for question 8. Maybe even a better hint, if I went 9 over 7, that would be 7 plus 2 over 7, which becomes 7 over 7. Hey guys, which is 1. And then I can integrate the 1 and so on. So that's your little bit of a hint for 8 when you get to it, okay? Let's keep going. 25 minutes, love you. You are going to have to do with your arc stuff some, what's it called? Definite integrals. So everything is the same. You do your thingy-majiggy, but what's going on here? How have they gone from arc sine root 3 on 2 to pi on 3? Yep, they've just gone shift sin. So shift sin root 3 on 2 and pi on 3. So sine of what is root 3 on 3? Root 3 on 2, pi on 3. So use your calculator. Yeah? That's how they get it. So not too bad, and then that's done. So I know it's a quick turnaround from today to tomorrow, but I do want to work on integration by substitution. And guess what? You repeat some of this stuff again. So please do as much as you can. Yeah, love you. I'm here at lunch if you want a dry spot, but I know you've also got friends and a break that you want to have.